All right, so I think this is a really, really special session. Why is it special? Because I think it wouldn't have been so interesting for people like a year ago, and now it's like really core and center. That's my intuition. Maybe Chaoyu correct me if it's different, but I'm hearing a lot more questions about open source models, custom models, RAG and private use cases. Because I think a lot of POCs were like, yeah, we'll do whatever we want. And now that it's, people say that 2024 is the year of productionizing. So when as you productionize, you go back to the real constraints you have. But I think this is a real and pretty common constraint. So uh, just a quick reminder, kind of set this in the chat. But if you'd like to ask questions or participate, then general chat within the Discord of LLMOps.Space. And it's in general, it's a great place for resources and for asking all sorts of things. So let's talk a bit about the community. So it's a global community for LLM practitioners. The idea is there's content, discussions within the Discord, the content that's on the website, and events. And we have pretty common events. So I think it's a great kind of place to join and get resources. Also, the events, we plan them kind of like a course in the sense that they're not meant for juniors, they're meant for mid-level and senior practitioners, but they're built in a way where we try to minimize the overlap. So if you just go from number one until where we are now, you're supposed to learn a lot. We have multiple types of events. We're also offering something where when there's a new product or module launch, you can do it within LLMOps.Space. Definitely up for getting speakers. So in the last couple of weeks, so this event was supposed to be last week. We postponed it by a week, and here we are now. So a bit of the updates that are relevant to kind of both areas, both weeks. So Databricks released a model, DBRX, which is seems like a very impressive general purpose model, 132 billion parameters. Mistral, which personally got to get a bit hands-on with, has released a new also large model, which is worth kind of looking at, where it's anyway, I think also really, really interesting architecture, and it's the previous models were very high performance, so it's definitely worth looking into. Cohere released a new model also. And Anthropic published a research, sorry, it says research instead of research paper, but or research blog on something called many-shot LLM jailbreaking, where what's new about this is it's kind of like other jailbreaking techniques that exist, but specifically for long prompts. So the idea is like you have a full conversation. It's almost like peer pressure from the way I see it. It's like you have input and then a illegitimate response that's written within the prompt, and then another part of the chat. So you're like kind of getting them used to the fact that the user is answering, or that the machine is, both sides are answering and continuing the illegitimate conversation, and then the model kind of continues it. So what's cool about this what's cool about this blog is that they showed that their own model also had a problem with it, and then they kind of leaked it or told it secretly to other research groups and then published it. So I think that's a really cool cultural thing. A bit about the general space. So I think there are a lot of great companies here in different areas, definitely kind of worth having a look at. And something a bit newer in the space is LLMOps.Space consultants. So there's a list here. If you're a consultant, you can also list yourself here, and also reach out to them. They're spread all over the world, and you can see a lot of what you usually have to take a first call to understand about them. And we did start to work on a new website, which will be more impressive than the Notion-like kind of website today. Anyway, that's all about the community. So a bit about the agenda for today. So we're going to talk about, I'm going to make some noise here, but most of the work is going to be done by Xiaoyu about self-hosting open source model LLMs, or embedding models for RAG, seamlessly chaining the LLMs with different components, different types of pipeline that are relevant, and leveraging BentoML for building kind of RAG as a service. So I hope it'll be interesting. Feel free to ask questions again in the Discord, not over here. And the previous interesting background of Chaoyu is early software engineer at Databricks, got all sorts of different titles, works on interesting projects, but we wanted to keep it kind of concise. And I think what he's doing now is really interesting, and you'll be the judges of that by the end of the session. So one last issue here. So DeepShek's the company that I work at, where we do LLM evaluation. So we have another event coming up the 16th. It's about, we did an integration with Honeycomb that has to do with observability in production. So I think it's going to be really interesting. I'll send a link here to also sign up for this. But again, it's a DeepShek's event and not an LLMOps.Space event. So, a bit different, but there are similarities. And yeah, and for future events, I did kind of, mention we're happy to accept speakers from different types, and there are different genres of how to do the talks. So feel free to reach out. Without further ado, I'll send the link for the next event here. Without further ado, feel free to take over.
Awesome. Thank you, Philip. Let me get my screen here. Philip, I might not be able to see the questions, but feel free to help me monitor if there are any questions want me to stop. Excited to be here. Thank you so much for the introduction. My name is Chaoyu. I'm the founder and CEO of BentoML. Today, I want to share some of the lessons we learned while building production RAG with some of our customers. A big focus here would be as you look into improve your RAG application's performance, scale things reliably, it comes with a lot of challenges around how do you utilize open source, fine-tune the custom models to improve your RAG pipeline, as well as self-hosting large generation model for data security and privacy reasons. At BentoML, we look at a lot of infrastructure challenges that comes with such a demand. And I will be discussing a lot of topics along that journey. Quick words about BentoML, the company that I'm building. We started the company in 2019. We have one of the most popular model serving library out there for building model inference services, building multi-modality apps, as well as LLM apps, where model inference will be a core component and how do you automatically optimize. As a company, we build the inference platform for enterprise AI teams for you to ship fast, secure, and scalable AI apps. I think after this talk, you will have a bit more sense about where BentoML comes in if you're building a RAG application. All right, let's dive into it.
Yeah, wait, just 1 second before you dive in. So so we're gonna do the first poll. We usually have a couple of polls here. So we're gonna start by the poll of which stage is your LLM-based app? So the options are conceptualization and design, development and testing, production and deployment, or optimization and skill. So let's see, I have some prediction in my mind for what this will look like. So I think you can move to the next slide, and after about one slide, then it's the time to kind of stop the survey in the meantime and show it.
Sounds good. So this is a fairly simple diagram showing what a typical RAG application is. I assume probably most audience here have seen different variants of this chart.
Yeah,
very simple RAG.
By the way, I just want to say, what I loved in the prep session that we had is I learned a lot about RAG just from this. Like, you kind of feel like you know everything, and then aside from the RAG being, in the open source or a kind of adaptable model constraints and so forth, private and so forth. So I also learned a lot about the foundation. So it might seem to you here like you kind of seen this before, but I promise you'll learn from the next slides. All right.
Yeah. This is a typical architecture. I think the core problem it's trying to solve here is by providing additional knowledge and context for large language model when answering a user's query or solving a specific task. And the way the typical things works is you have large chunk of data set, unstructured or structured. You break them down into small chunks, each containing a piece of information. You run it over a text embedding model, which helps you learn the meanings. It's trying to represent the meanings in those words, those chunks, and put that into a vector database where when the user query comes in, you can find relevant chunks put them together, and provide that to a large language model as context for answering a question. And typically, we see people starting with just the text embedding model and large language model over external third-party APIs for accessing those AI models. This is something with the modern orchestration framework you can get it done within 5 to 10 lines of Python code. But of course, with just a few lines of Python code, you can imagine you'll be running into all sorts of challenges when you're working on real-world data set or looking to improve its performance.
Wait, just 1 second before the slide, I'll show the results of the poll. Sorry about that.
Let's take a look.
So yeah, all right. So 42% are in conceptualization and design, 45% are in development and testing, production and deployment 23%, and optimization and scaling is 13%. So we actually have more than a third are already at the point where they have at least one app that's production or really close to production, which is potentially more than the average event. So not surprised because the topic is one of the bit more advanced ones, but where you don't need it like for the very first PRC of yours. But anyway, great. So
That's
back to you.
amazing to see. Awesome. Yeah. Especially for those folks already in development and production stage, these problems you are probably very familiar with. Retrieval performance is a huge one. And I think in general, I think the first couple components like data ingestion, figure out how do you do embedding, do chunking, and then improving that retrieval performance and quality tends to be the most important factors in how your RAG performs. There's also things such as response synthesis, as well as evaluation. I think that's something Philip has been expert in that area. When you start looking at those challenges, RAG start to grow in its complexity. So I will go through a couple of those type of kind of decisions you will have to make in that journey. The first and quite obvious one is the text embedding model. The default text embedding model everyone is going after is actually not the state of art or the top ranked model in the text embedding leaderboard for English, right? And especially if you're working with minor languages or working with very domain specific type of languages, they are even worse at their performance. So a lot of time, you may want to look into fine-tuning of the embedding model in order to have a much better representation over your own data set. This is a diagram from 3Blue, Brown. They just recently did a fantastic video. I think it's a great illustration showing the intuition is that the embedding models are trained to represent different meanings, ideas in high dimensional vector space. So in this diagram, for example, you can see this one direction somehow intuitively encodes the gender information. And a generic text embedding model will have limited embedding space to encode all sort of information and different type of meaning into that space. I guess the idea is that by your own data set, the data set you are working with may have a lot of domain-specific ideas and concepts, and they may live very close to each other in that generic embedding space. So by going through the fine-tuning space, you can actually further differentiate them and have more embedding space reserved for this type of data you are working with.
I'll give you the first question from the audience. The question from Pankaj, is it common to store extracted embeddings even when you're using a search backends, or is it more common to discard and recompute? How do you see that changing in the future? So I'm not sure if I got it 100%. If I understand correctly, the question is if it's the same embeddings both for general search use cases and for the RAG use case with the same type of data, but I'm not sure I got it correctly.
I'm not sure I fully understand the question, but it's a question about late compute, something like covert architecture.
Yeah, maybe Pankaj, maybe try to elaborate more in the Discord, and I'll try to re-ask it once I kind of get it. That's anyway. So let's continue in the meantime.
Sounds good. So the second decision people often run into is choosing a large language model. This is mainly used for synthesizing the response. But people started to use it for a number of other tasks that we'll see a bit later. If you look at the rankings, GPT-4 is still the best performing large language model. But I think while you're making this decision, a few key questions to ask is one, what level of security and data privacy and control you need? Oftentimes we see people working with very sensitive data come to self-hosting open source large language models that is pre-trained off the shelf or customized, fine-tuned over their own data set. If you are working with that type of data, this is probably what you have to do. On the other side, it's the latency requirements, the type of cost you're looking at, and the quality you need. Those are important no matter you're using open source model, commercial model. Depending on those three different criteria, you might be looking at a really capable model that's very expensive, very slow. You can use that for the evaluation stage, for curating data set, for evaluation, for something that really needs strong reasoning and doesn't care too much about cost. But as let's say you want to scale the querying QA system to millions of users, the cost becomes a concern. That's where you can perhaps adopt a smaller language model that's much faster, cheaper, but have good enough quality if you provide it with enough context. So those two are sort of table stakes that everyone is looking at. But next, I want to go through a couple scenarios that you will quickly start learning about as you look to improve the retrieval quality, especially. The first one is context-aware chunking. I think by default, most of the RAG systems go with a fixed size chunking, which you just take a document, split into equally sized chunks, and have certain amount of overlap between chunks. So that way, when you're retrieving information, each chunk fits within the dense embedding context window. The problem with that is oftentimes you're losing a lot of context and meaning in that process. The context-aware chunking typically adopts a natural language processing model that helps you understand the structure of the document you're parsing and being able to inject more semantic meanings along the way, and helps you chunk the documents into appropriate size chunks that have the meaning. And this can oftentimes be used in the retrieval time as well. Let's say you retrieved only one part in the bigger paragraph, but you can take that whole paragraph in the synthesized stage for the LLM as its context. So being able to parse this structured meaning can significantly help and enable you to do more in the later stage of your RAG application.
Right, just about this thing, just 1 second, one thought about this. So we had actually a session here about RAG fundamentals or advanced RAG, and a question that came up about the chunking is, okay, I mean, why don't you need this? Like, why can't you just use something like how can you use something that's not like spacey, right? Can you just like take a random chunk or whatever? So the answer is yes. Like, it does work, even if you're like, you're not cutting it well and you get like extra, you can't have less than the sentences you need. But if you have more up at the beginning, it might look not clean, and if you read it, it might bother you. But it turns out that LLMs know how to get over it. So I think, like Chaoyu mentioned now, it's better when you manage to do this. Forget compute aside, code aside, operations aside, like things you have to add. It's better if it's cleaner, but it's like, I think it's actually, maybe correct me if I'm mistaken, I think it's actually more common to have like ugly chunking kind of, but I don't know what you're seeing more. So ugly chunking,
Right.
It works less good, but it works, and that's, I think, pretty common.
Completely agree. I think oftentimes, I think more important is the context can be stored together. Actually, that's something I'll be covering in a second. But those sort of contexts typically can help for other things other than chunking as well. So this is probably more generic about parsing the context where the document, where the chunk sits in the overall documents, and how that can be helpful. Fixed size chunking can go a long way. I definitely hear that. But then the problem comes with the challenges typically are figuring out the right chunk size over your specific type of data set. Cool. So the next section I want to talk about is unstructured data. So not all data comes in with a clean and nicely formatted, structured way. Real-world documents are often really challenged to work with. Here are a couple examples like PDF files with charts, with tables, with lists. And it's really hard to get a generic solution that just OCR and recognize the text on the PDF. You're losing out a lot of information here. But there are tons of really good open source models, or you can easily train your own models that helps you do document layout analysis to help you extract the information in a table, detect those tables. There are also tons of research. You can run various models very cheaply to do things like entity extraction, topic classifications, things like that. That helps you get additional metadata extracted from the document. And of course, with all those metadata, let's say you parse the information from a PDF, or in this case on the screen, that's parsing additional metadata from a product review on Amazon, let's say. You can use sentiment analysis model to understand this sentiment. You can run the summarization on top. You can list out the keywords and topics. And those metadata information are really cheap to compute, but helps tremendously if you can utilize it in the retrieval pipeline, knowing, let's say which specific product the user is looking for, and use the summary for, more traditional BM25 search. And this helps tremendously to filter down the type of chunks you want to retrieve for the large language model to see. This goes back to the context-aware chunking. I think a lot of those NLP techniques, if you don't use it for chunking, you can at least use it for understanding context and store that along with the metadata. One example is, let's say you're doing a RAG over financial documents, PDF filings. It will be important if you can extract some of the key numbers or conclusions of a research paper differently, or store that metadata separately, and give them a higher score in the retrieval process. I know I'm covering a lot of models. Reranker is probably the most important model to look into. There are commercial posted versions available. There are also a lot of open source options you could look into. The general idea is that when you just do an embedding similarity search, you may end up finding tons of documents that are relevant to a user's question, but that might not be true. So a re-ranker model essentially looks at all those relevant records and say, these three are essentially what you need for answering this question. So they will be ranked much higher and when given to the large language model. And depending on the model's window size, you may play around with where you put those more important information and help LLM to generate a better answer.
Yeah, by the way, I was pretty ignorant about re-rankers until really recently. Like I don't realize how common it is. So it's like, why do you need a re-ranker? Why can't you just have it ranked well the first time? So it turns out that it's just not as common. So like to do it in two shot kind of, and not one.
That's right. That's right. There are a lot of research here that combining different type of re-ranker models, different embedding models. You typically see a pretty significant retrieval performance gain. Yeah. And lastly, this is somewhat a bit new, but there are new research and new techniques that will allow you to do cross-modality retrieval. I know this in practice is less common, but what's more common is people use more, I guess, widely adopted models like Clip or Blip to do visual reasoning to understand what's going on in an image and use that as part of the RAG pipeline, being able to work with external image data. All right, so I've gone through quite a few models, and a lot of them are really essential as you scale graph into production. You ended up with a graph that looks like this, right? You are in no time, you go from a simple Python program that calls to external API to a program that involves a tons of different models. Some of those models can run pretty decently on CPU. A lot of them will need different sizes of GPU to run efficiently. This becomes a very challenging system to run and operate in practice. So that's something, I guess, a quick recap of what we've seen so far. The production rack system, you often need to run a number of AI ML models. And because those models are customized, fine-tuned models, because in production, you start concerning about data privacy, cost, and latency. A lot of time you need to run those models with your own infrastructure, and that can be a huge challenge. So that comes in the next part of this talk is where I want to discuss how what's the state of our, I guess, the infrastructure open source options available and what we're doing with BentoML in this space. To begin with, if you're just looking to self.
So just 1 second, I want to give another question or two, because I think we're now going a bit more towards the self-hosting and a bit far from the RAG part, which is, again, there's a lot to learn just in the foundations, even when we feel we already know everything. So there's a question here, why use RAG on tabular data like financial data? You can already query it traditionally. I don't see this use case immediately. So I'll say on my end, I really don't think it's that common. Sometimes anything that can be represented well by embeddings, then it does make sometimes sense. I do know cases of embedding of tabular data and so forth, but it's pretty rare. I think you should assume that most of what you saw here is for text, and in some cases, computer vision. I think there are use cases also for time series, but really, really rare. I don't think it's tabular data, right? Is that
that's still pretty rare, yeah.
Okay, great. So that's one question. The next question is from Sean and I in the Discord. Thank you, Chaoyu, for a great presentation so far. Can you please provide some examples that we can use for those tools for understanding various document formats? What are you using to analyze those charts, structures, and so forth? So, I mean, just to break it down, the most vanilla part is just having plain text, right? And then, of course, when you chunk it, you can get paragraph by paragraph. But then some of the things you mentioned here are really interesting. So I think you can feel free.
I see. Yeah. I think those models actually exist for a pretty long time. I would highly recommend just go to Hugging Face. In the models section, you can actually find a category of models called table like layout analysis. And I think most of those state-of-art models performs quite well. You do want to look into the type of PDFs or documents that are being trained on. Some performs better on this type of complex PDF structure. Some performs better on, let's say, handwritten receipts or handwritten documents. And the table structure recognition is also super common. I think we've been building BentoML for 4.5 years. This type of OCR pipeline actually consists of a very important use case that we've been supporting for years. Of course, these are things that you can do yourself, and you can optimize things for your own type of data you're working with. If you're just getting started, there are also fully hosted solutions out there that helps you understand unstructured data and extract as much information as possible. I think set cost aside, that's definitely a very convenient way for you to get started. And as over time if you run into problems while evaluating your RAG pipeline, identify, maybe this important piece of information in this document is not properly parsed. You can start looking into some of these more advanced techniques for getting those information into your RAG system.
Right. Okay. Now I'm just kind of connecting dots here. So Smorgas part before that asked a question about tabular data. So I think he was asking about this. So the answer why it's interesting to use this in RAG is that it's in a document where it's not a fixed structure. This comes like within the text, or you can have different types of tables and so forth. So you can retrieve like a table that your code doesn't know how to work with, then give it to an LLM, and the LLM is part of what kind of organizing it or can kind of work with it. It doesn't always work well, but it's a lot of times it's much better than having nothing, and it takes a long time to write like the kind of if else type code for this. All right.
That's right. Yeah. Sometimes those tables doesn't necessarily need to go through embedding, right? It could be you recognize all the PDF files you work with typically have this table towards the end. You can parse that information and put that as part of the metadata filtering process, or even run export that out, run additional analytics, do your own type of search over that type of structured data. So a lot of things there you could do, and we will cover a little bit about router model, which allows you to choose data source you want to use during the response synthetic stage.
All right, great. So I think we can move. We have some more questions, but I'm handling some of them at least in text within the Discord. So feel free to progress to the next part. And
sounds good. So I guess the first problem is if you're looking to just self-host large language model part, there are tons of best practices in running inference with large language model. I know the first thing people would try is probably just downloading the model from Hugging Face, use PyTorch to load the model and run it. That's good enough if you're just doing the proof of concept, trying out the model, but that's incredibly slow and inefficient for production scenarios. There are tons of options I put on the screen. They're all open source with different licenses, but they typically involve those common best practices and inference optimization I have on the left side. And one particularly important thing to look for is that the framework allows you to do lower level customization, like stop condition, like the output format enforcing. Those are really, really helpful features that can help you make your RAG response generation more efficient. Another aspect beyond the inference server is scaling things in production. Large language model behaves very differently than a lot of traditional workload. If you just look at the GPU metrics of a machine that's running LLM, it may tell you the GPU is 100% utilized. But in fact, you can actually add loads more requests to it. And that's why this Bento Cloud, our enterprise product, and many other products in this space offers concurrency-based auto-scaling, which lets the infrastructure really understand the semantic meanings of different type of requests, how things are being dynamically batched, and utilize that information along with the resource utilization to help you determine how things should scale. And of course, there also comes with challenges, like you're working with a much, much larger Docker image with all the CUDA libraries, with the huge model files you need to download. How do you keep up with the infrastructure so things can scale fast enough to meet your demands? And the second most common model is embedding model. If you have a fine-tuned embedding model looking to serve it, I highly recommend looking to our model serving library, BentoML. One specific feature I want to mention here is dynamic batching. Intuitively, most of the model inference runtimes and CPU, GPUs are optimized for batch processing, especially during training. You're looking at batch data set at one time. But inference time, you often get one request at a time and processing one item at the time. With that type of pattern, you're actually wasting a lot of the compute resources available. What dynamic batching does is while the server is receiving requests, it puts them into a smaller group and run that through the model at once, and having a dispatcher that dynamically decides the batch size and the wait time for you. In our case, we spent time out just by enabling this one flag actual true. We see anywhere between 2 to 3x improvement on latency, while almost doubling the throughput. So that's a huge performance gain if you're not already doing this today. I guess the key takeaway here is that if you're looking to run an open source model or fine-tune the model, there are tons of work on the infrastructure certain side has been done in the industry, and definitely utilize those open source tools available to help you speed up that process. Besides serving those individual models,
just 1 second. I was just thinking, no, not a question. I was just thinking, when's a good time to run our next poll. So I think I'm going to do it now. So
okay.
The next poll I'm launching now is, what type of LLM are you currently using? Of course, if it's not you directly, if it's someone from your team, then feel free to add that in. The questions are private LLM via API, like OpenAI or Anthropic and so forth. There's open source LLM via an endpoint provider, like Bedrock. There's self-hosted open source LLM endpoint, and there's fine-tuned model, which means open source or private. I know that it doesn't cover all options, but go with the closest one. And well, I'm already getting surprised, but I won't tell you why. We'll see that. I want you to be in suspense. So we'll see that next slide.
That's good. Oh. All right. So the next couple slides, I want to go through a very core concept in building this type of production-facing RAG system, especially with private deployed models. I will go through three main scenarios where it can help you conceptualize how this works, why it's necessary,
Wait, just 1 second. There are a couple of questions about dynamic batching. Should I do it now, or I should wait till the end of the slide and then go back?
how are we doing on time?
I
Probably
think
have
I think
like three or four more slides.
Yeah, I think we have time. So let's go over them. So one question is what are the considerations in dynamic batching of requests technically? That's one question. And the other one is if you can make a model process faster by dynamically restricting max token output or something like that. Where it starts answering first like the short forms and so forth when there's a lot of a load where if you have an estimate for what the length of the output is. I like the idea actually, Smorgasbord. So if you have an estimate about how long it is, then maybe you could say, okay, let's get to those later. My intuition is it's a great idea, but you don't have an estimate early on, at least without extra development. But those are the two questions.
That's a great question. So although I think that's more related to continuous batching in large language model hosting. So continuous batching, you can actually do some of those techniques, like deciding if the query is running too long, if you want to end it earlier, you can always stop that generation. Actually, that's a pretty easy thing to do if you're running, let's say, BentoML with VLM. You can easily control that, or you can have even have external influential, let's say, run the separate model to determine if this generation is still relevant, if it should take out of the queue that's being processed in the current batch. For dynamic batching, it's more often used. I guess for oftentimes it's fixed size window that you have a batch of input for the model. The key consideration here is oftentimes what's the ideal batch size. So a lot of systems that we see is you set a fixed batch size and fixed wait window. So if you're just sending one request to the server and you set the wait time to 1 second, the request is always going to come back after 1 second. It's trying to wait, see if there's more requests coming in. But a lot of the more modern systems like BentoML actually does this in a slightly more smarter way. Like initially when requests come in, it tries to learn the patterns, how long each request takes to run inference, and the inference time for different batch sizes, if you allow it to be different sizes. And then as more requests comes in, it learns the pattern and dynamic decides the ideal wait time and batch sizes for your particular workload. So that's something like applying a little bit ML technique in the serving system itself. We see a tremendous gain in developer productivity as well as the performance. The developer no longer need to think about the trade-off between wait time, batch size, but the system is being able to evolve over time and perform better.
Okay, great. So 1 second before you continue, if we already did a distraction, so I'll end the poll here, and I'll share the results. So this is pretty amazing. So private LLM via API is just a bit ahead. 48% is like OpenAI and similar. It has to do with the topic, of course, but open source LLM via an endpoint provider, where there are definitely quite a few, right? Like there's, I don't know, they have the smaller ones, the size like OpenPipe type. There's AWS, of course, Bedrock, and there's Databricks, and I think there are quite a few others. And it does save a headache and also help with pricing and so forth. But self-hosted open source is not that far behind. So I think a lot of times you just need it in terms of security. It really depends on the specific security considerations of your organization. But we definitely see that here. And then fine-tuned model. Again, I know this wasn't the most rigorous question, so it might have to do with the the endpoint providers, where not all of them offer the fine-tuned kind of hosting, but some do. When they do, it's always via, LoRa or similar. LoRa, for those that don't know, is like a way to have one model serve a few different fine-tunes by like having kind of like different classes for each user. We had a separate session on that, but really, really interesting. A lot of open source folks here, and let's continue.
All right. So a few examples that's utilizing model composition. This will be the main topic of the next few slides. We talk about composing the different layout analysis, table extraction pipeline in practice. Running so many different models to go through a pipeline of things. For example, visual reasoning model might be a slightly larger model that requires a GPU. But let's say entity extraction might be a much smaller model. You can run on a small GPU or CPU. You are starting dealing with a distributed system on different microservices that's managing and hosting different type of models. Very soon you will realize the end-to-end latency and being able to optimize different parts of the application becomes extremely complex. Sometimes you want to run the pipeline in a batch-oriented way. Let's say you're processing 10,000 documents and embed them into a vector database. Sometimes it might be real-time user uploading a document and you want to process it faster. So they all come with different needs for the infrastructure. I will keep it a little bit high level on the problem that's solving here. Another typical scenario is applying a smaller language model. That could be a BERT-based model for classification, could be something like a T5 for much smaller model. Here I showed two use cases. One is, let's say, based on user query. You can actually use a small model to quickly define if this is a toxic or harmful request, and in which case you can just reject the user request, give a generic information like response, right? You don't have to use the more expensive resources to do retrieval and generation at all. And then the second stage here is based on the user's query. Sometimes you might be using an agentic workflow or utilizing many different data sources. People use LLM for figuring out this today, but this is oftentimes can be very easily done with a fine-tuned classification model. Often in orchestration framework, this is called a router that based on the user query and decide which are the tools I need and which are the data sources I should be doing the retrieval. Right. And similar techniques can be used in many other places. There are also projects like DSPy, where it helps you automatically figure out some of those opportunities for this type of optimization. And lastly, when you put all those different components into production, the challenges comes with managing many different moving parts, being able to evaluate different versions of them, testing them, and deploying them becomes a huge pain point. So what BentoML offers developer to do is you can develop each individual services separately. You can have OCR services that have multiple models, have a text embedding models standalone, and have a large image model service standalone. Each have different shape and size in terms of its compute resource requirements. But then putting them all together as dependencies, and this allows BentoML to build that distributed deployment graph of different models, and allowing each of them can be easily invoking each other through a very simple Python function calling interface. And we translate that into RPCs between different services and optimize the communication, the serialization between services, and as well as allow each component to scale independently depending on the workload. For example, this rack service, you can set the OCR service to scale down to 0. So it's only being scaled up or being actively utilized when you're running data ingestion. Right? But other times when you're doing query, you may just need the embedding model and BLM service instead. A huge benefit of this way is you can think of you are versioning all your code configs into one place and managed in one artifact that's built and reproducible. So this allows you, let's say you have two different versions of the app, use very different chunking technique, different embedding models, and then you want to compare their output, their performance to evaluation. This allows you very easily to do very different the version of the entire RAG stack, make that reproducible and make that quickly deployable to the cloud and run your evaluation set, understand which approach works better, and you're evaluating the entire RAG stack end to end. All right, so that's the end of the presentation. I want to do a quick recap. Production RAG often involves running multiple models. I think one paper that I really like is the Compound AI System by Matei's group. A lot of the state-of-the-art AI results, it requires multiple components, not just one monolithic model. And especially for RAG, I think scaling all those components together and each with different needs really requires specialized infrastructure tooling. That's a very interesting problem BentoML is solving. Definitely check us out on GitHub, and would love to hear more questions.
All right, amazing. So I think there are no oh, 1 second. So now there was a question by Vaishnav that service bus also works, right? I'm not sure what it was referring to, but I'm guessing that if you have a sense for that, then answer the question. If not, then I'll ask for clarification.
I haven't heard
Okay,
about
so
that.
Vaishnav, you have to say what service bus works for instead. All right. So we have a couple of folks typing here, but I'll take one of them, that was asked over here. So 1 second. So there's a question of can these self-host models be used for proprietary data? So the answer is of course, right? Like that's the whole point. Yeah, so that's the whole point. You're not reaching to a third-party API. Everything happens within either like your account, or in cases like AWS or Azure or GCP, then it's like or similar. Then it's within like a central managed service. They have different settings of security. So yeah, it's kind of built. I don't want to say especially for that, but almost especially for that. So we had a question from Cedric earlier on. Do we have any rough benchmarks about the impact of document preprocessing quality and the overall RAG performance? So maybe you take this one, and if I have something to add, then I can add.
I see. It's really hard to give a really generic answer. This really depends on the space that you're working with. But I think it's a slam dunk. It's pretty obvious. Let's say you're working with OCR over text data that's managing a lot of help documentations, right? Being able to understand the topics really quickly and then filter down to those specific topics in your retrieval pipeline can tremendously reduce the risk of the reranker model or the LLM hallucinating, not understanding the context correctly. You're essentially using something that's a very strong signal. This is very common in a lot of the traditional information retrieval system as well. Traditional information retrieval system use hundreds of thousands of signals, but LLM is really smart with complex text, but RAG is not. But without those additional metadata, it's oftentimes even fail to compete with a more traditional search system.
Mm-hmm. Okay, amazing. So I'll add on my sense. I just think what I think is really cool here, this is something that we've been working on at DeepChecks. DeepChecks, I mentioned we do LLM evaluation. So what does it mean like overall performance, so the RAG performance? So I think that's something that's really cool, and it's not always done, where if you end up having like a really specific golden data set or evaluation data set together with automatic scoring, which is like something that we're putting a lot of emphasis on now, then you can you can play all sorts of games much earlier in the pipeline, like in the the chunking strategy, or are you using the spacey kind of method of separating the chunks, or you're just doing it like a bare metal kind of. Or you could also say, okay, I'll take the entire document and just clean it, and then I'll chunk it, or not. So you can run experiments like deep within the vector search or vector database, that kind of area, and then see how it impacts. At the end, you see, is it an 82 score, or a 76 score. So I hope to demo this here sometime, like with the exact workflow, and have a technical blog post kind of showing this. But we've been doing it. It's really cool, and it enables making like informed decisions. But you need to have for that both automatic scoring and like a pretty good data set. And then yeah, will it impact it? I mean, I think it's pretty clear that it does. Sometimes you know the questions are just easy, then you don't feel the difference. But when the questions are hard and there's a low percentage, like if your overall thumbs up is, I don't know, 56%, you'll feel the difference. Yeah, so I know we have other questions, but as we like to say sometimes, the deadline is the most important feature. So but you know, Xiaoyu, maybe if you manage to do it, there was a lot of interest. So in the general chat now in the Discord, you manage now to go and answer people. Whoever's interested, please stay online, and hopefully we'll manage to also get to some interesting one-on-ones. Again, quick reminder, we don't have the date for the next LLMOps.Space event. The next an event that we're having now with Deep Checks together with Honeycomb is going to be on the 16th, and really next week. And we have quite a few interesting upcoming events. I'm urging again, you know, especially if you're as good as Xiaoyu, then please reach out as a speaker. And we're building like the syllabus and looking at all the next talks. So would love to have you reach out, either propose, you know, offer yourself or offer some colleagues of yours, and see you around. All right.
Thank you.